welcome. In this lecture on linear data analysis, which has multiple sessions, we'll explore the diagonalizability of a matrix. The main concepts for this is, first, we'll recall what we mean by matrices being similar. Then we'll see what it means for a matrix to be diagonalizable. And for such a matrix, we'll consider how can we rapidly find powers of such a matrix. As we go through this lecture, we can keep in mind this problem, which is what is the square root of an invertible matrix? So let's recall from prerequisite courses what we mean by a similar matrix. First, we'll deal with the more general concept of matrices being equivalent. So when we have any two matrices A and C, we say they're equivalent if there are a pair of invertible matrices, P1 and P2, such that if we take our matrix A and we pre-multiply by P and we post-multiply by P2, then we get that matrix C. So that means that this is equivalent to this. One example of where you may have come across equivalent matrices is when trying to solve a linear equation, such as AX equals B. In a problem such as that, we would find the LU decomposition of A, and what we end up with is an equivalent matrix system. Now, two matrices A and C are similar. This is a stronger statement. And what it means is that if we take the matrix A, we can pre-multiply by an invertible P and post-multiply by the inverse of that P, and we end up with C. And here, this has to be the same matrix, and you can see that, for example, what this would do is it require that this P2 is the inverse of that P1. So similarity is a stronger requirement on a pair of matrices A and C. One important case that we'll care about for the rest of this lecture is when this matrix C is a diagonal matrix.